for the given sequence, we're going to find the sum of the first n terms. We have 1 times 2, comma, 2 times 3, comma, 3 times 4. So the next one would be 4 times 5, and so forth. So let's look and see what we have. We have 1 times 2, 2 times 3, comma, and 3 times 4, comma, and then little line dots here, since it's a sequence. All right, so basically this is your first term, this is your second term, and this is your third term. And then you would go all the way to your nth term somewhere down here. All right, so looking at this, what we want to do is look at these index numbers. So to find your nth term, you notice that these match up. There's the pattern. Since these match up, that's just going to be n. So when you substitute in 1, you're going to get 1 here. To get the next number, that's just 1 higher. So that's going to be n plus 1. So that is your sequence. And now we want to find the sum. So the sum is going to be written as S sub n equals the sum. And you can use K or J or something, but we'll use K here. K equals 1 to n of K times K plus 1. So I just rewrote it because we need to go to n, so I rewrote this with K. All right, so let's go ahead and finish this up. And I'll write this up again here. We have the sum of K equals 1 to n K times K plus 1. And this actually equals the sum. K equals 1 to n. Let's go ahead and distribute this. K squared plus K. And I have formulas here for common formulas for the sums that we're going to be using. So let's break this up and write this as the sum from K equals 1 to n of K squared plus the sum from K equals 1 to n of K. Now, what this is going to do is just use these formulas. This is your K squared formula, and this is just your K formula. So we can write this as equal to, for the K squared, that's n times n plus 1 times 2n plus 1, all divided by 6. And then for K, this is going to be n times n plus 1, all divided by 2. And the next step we want to do is get the common denominator. Our common denominator is 6, so I have to multiply this by 3. And when you do that, we'll have this. So that's one step. I'm cheating here a little bit, and just this is going to be 6, right? Now the next step is to factor out what we can. Let's factor out this n times n plus 1, because they both have n times n plus 1. And then see what we have left. So if I factor out n times n plus 1, I'm going to get 2n plus 1 here. This is 2n plus 1. And I'm going to be left with this 3 here. So I'll just put the 3 here, all divided by 6. All right, so from there, let's add this up. This is going to be n times n plus 1, and this is going to be 2n plus 4 divided by 6. All right. I can factor out a 2 here. So if I factor out a 2, trying to save room here. If I factor out a 2, what's going to happen is I'm going to get n times n plus 1 times n plus 2 divided by 6 times 2. And what's going to happen is this will cancel out, and 2 divided by 6 is 1/3, so you can put a 3 there. Sorry, I'm trying to save a little room so I don't have to rewrite some stuff. There you go. And that is your final answer. Thank you. Have a nice day. Bye-bye.